Hi friends, welcome to the Unit 3 Day 2 notes. Today we're going to be talking about the remainder theorem. The remainder theorem essentially is saying that if you divide a polynomial by x minus c, then whatever your remainder is equal to if you plugged in that c value back into your polynomial. So for example, if we divide x cubed plus 3x squared minus 4x minus 2 by x plus 12, we got x squared plus x minus 6. We've actually done that problem in a previous video. That means that negative 2 is a 0 of this because x plus 2 is a factor of this original polynomial. So the remainder, or the result that's left, is 0. That's important to know. That's an x-intercept if we were to graph it. That gives us a lot of information. So what I want to do is I want to go through and do this division. I'm going to divide using synthetic division, and then I want to plug in negative 3 back into what our original problem was, not the division part. Again, if I had plugged in negative 3 here, we're dividing by 0, we can't do that. But I want to point out what the remainder is when we plug that in. So what really works out well for this particular part is if you, again, pause the video, try it on your own, and then check to see what our answers are. So if you haven't, go ahead and take a moment, pause the video, and rejoin me when you have this part and this part finished. All right, so let's go ahead and jump through. I'm going to take negative 3 here, again using synthetic division. So then my coefficients are 1x cubed, 5x squared, 2x, and then negative 8. I'm going to bring down the 1. 1 times negative 3 is negative 3, positive 2. Negative 6, 2 minus 6 is negative 4. Negative 4 times negative 3 is positive 12. So I have a remainder here of 4. I want to point out that's the remainder. The remainder part is 4. It's 4 over x plus 3, but 4 is kind of the key thing that we're going to note here. If I plug in negative 3 into, again, just my numerator, then I have negative 3 quantity cubed plus 5 times negative 3 squared plus 2 times negative 3, and then minus 8. Negative 3 to the third power cubed is negative 27. Plus, so this is going to be a positive 9. 9 times 5 is 45, plus 45, minus 6, minus 8. Then we go from left to right. Negative 27 plus 45 is a positive 18. So I have 18 minus 6 minus 8. 18 minus 6 is 12. And then 12 minus 8 is 4. So these values are the same. They are the same. They also tell us a few other things. Graphically, if I plugged in negative 3 into this graph and found what my y value was, I would actually have a point at negative 3 comma 4. So we're going to see that here soon also. So that's our remainder theorem. I'm going to go ahead and jump into this example also. So we're going to find we're going to use the remainder theorem to find p of negative 5 for this, and then verifying the result using a substitution. So I'm actually going to do the synthetic division first. So negative 5, again, my coefficients are 1x to the 4th, 3x cubed, negative 8x squared, 5x, and then negative 6. Bring down the 1. 1 times negative 5 is negative 5. 3 plus negative 5 is negative 2. That's positive 10. Positive 2. 2 times negative 5 is negative 10. Negative 5. And here I have positive 25. So my remainder in this case is 19. So when I plug in negative 5 into this, I should also get a 19. So p of negative 5 is equal to negative 5 to the 4th plus 3 times negative 5 cubed minus 8 times negative 5 squared plus 5 times negative 5 minus 6. So verifying, again, going through and verifying each of the steps. Negative 5 to the 4th power is 625. Negative 5 cubed is negative 125. Negative 125 times 3 is negative 375. Negative 5 squared is a positive 25. Positive 25 times negative 8 is minus 200. And then minus 25, and then minus 6. So if I subtract these off from 625 in order here, from left to right, I should end up with a 19. 625 minus 375 is 250. Yeah, 250. Minus 200, minus 25, minus 6. 250 minus 200 is 50. Minus 25 minus 6. 15 minus 25 is 25. 25 minus 6 is 19. Notice I showed each of these steps in as I went through and did these parts. That's very important if you're going to show your work on a homework assignment, quiz, or test. Make sure you show all of your work when you're verifying. This part I was able to do in my head, but if I used a calculator, it's perfectly fine. Just make sure you show your result. I did combine a few steps here with multiplying this value, doing my powers and then doing that. Perfectly fine, but make sure that when you go through each part, again, show more work than necessary. In the next video, we're going to really focus on the factor theorem, because in this case, now when we get that value of 0, then it tells us a specific instance, it being a factor, and what we can do with that. I'll see you in the next video.